Hi, I'm James McGuire, and our topic today is container technology, which is certainly influencing software development and cloud computing and microservices and all sorts of other tech topics. To talk about that, we have a leading expert in the field. With me is Gordon Haff, technology evangelist for Red Hat. Hey, Gordon, how are you doing today?
Hey, James, good to talk to you again.
So, I love your actual job title is technology evangelist. I've always loved that you have the word evangelist in your job title. It seems like a wonderfully open-ended job title to have.
Well, and I used to go by cloud evangelist, and then that was too narrow. So I went even broader with technology. So I can pass myself off as an expert on absolutely anything, which, given I was an industry analyst, is a pretty good transition.
Right. Okay. Great. So, containers, I mean, it's really in the last few years, obviously containers have been very much on the upswing. And I think there's still a lot of confusion about virtual machines versus containers and how those two fit together, and whether or not containers are good for legacy apps and the kind of effect they have. So let's do a little sort of a 101 background thing. I think it might be basic for some folks, but I think it's worth doing. Talk about what exactly containers are as they relate to virtual machines. So what are containers, and why are they so ideal for cloud computing?
Sure. Now, containers have actually been around for a long time in some form. They actually go back to BSD jails, I think 1990s, 1980s, maybe even. And so they've been around for a long time. Basically, what a container is in its simplest form, and containers become interesting for a lot of other reasons, which I'm sure we'll get into here. But in its very basic form, Unix and a lot of other modern operating systems have this idea of resource groups or process groups, ways to let an application execute a bunch of bits to do something. And it provides various types of isolation mechanisms so that those don't get in each other's way. So, one application running in a system doesn't suck up all the CPU and memory and so forth. So, or interfere, have security holes relative to other applications, that kind of thing. So basically what containers were originally, what BSD jails were originally, were they added some isolation to those basically Unix concepts, those Unix processes. And what has then happened over time was there were more resource management put on, more types of isolation techniques. This came into Linux, something called LXC originally, and there were actually some commercial products based in containers, but they were always very niche. Mostly service providers used them. SWSoft was an example of one container-based technology. And these changes, what they basically did from the point of view of the user, point of view of the application, was they looked somewhat like separate systems. So if you were running in a container, you thought that you had all of the resources of a full physical system, but in fact, you only had some of them. And in this respect, is conceptually similar to virtual machines, except that in the case of virtual machines, you have a layer basically sitting on the hardware. And in the case of containers, that layer is in the operating system, basically. And that's why containers are so tied up with Linux and the operating system.
Well, and of course, for the virtual machine, it carries its own operating system or the necessary operating system with it as it goes, correct?
Correct. And in fact, again, not to spend too much time in the historical context here, but I would argue there was somewhat of a battle between virtual machines and containers back around 2000, 2001 or thereabouts, over which technology was going to win to split up physical servers, these very underutilized physical servers. The bomb had happened, .com crash had happened, right. No one had any money, servers were often 15% utilized, and suddenly there was these software techniques that say, hey, you can maybe do 3 times as much work without buying any more servers. And people were sort of going, well, sign me up.
Using virtualization, you mean?
Well, at the time, you could have done it using virtualization. Virtuoso with SWSoft was arguing you could do it with containers. Sun was arguing you could do it with containers with Solaris. But what really happened was, first of all, IT only has an appetite for bringing in so much technology at one time. So it was a situation where somebody was going to really win this. And what happened was, at the time, there were a lot of what we would today call snowflake servers. So by that, what I mean is you've got an application on a specially tuned particular version of an operating system, and those kind of had to stay together. And containers really weren't very good for that, because containers virtualize the operating system. Everything needs to pretty much be running on the same version of the operating system. Also weren't really a good match with Windows at the time. So the hardware virtualization idea, which VMware initially won out at, was just a better model for these data centers with all kinds of different operating system versions and applications.
And certainly the enterprises flocked to, virtualization, and VMware in particular. They built an empire over, by, 2009, 2010, 12, somewhere in there. It was just VMware was long by the default virtualization layer for the enterprise.
Yeah. Certainly since that time, open source virtualization, KVM in particular, has made pretty significant inroads, but you're absolutely right. And partly it was increased utilization. The other thing that happened over time was that virtualization got into things like live migration and storage pooling and all kinds of, by the fact that you were abstracting the hardware, by the fact that you were kind of inserting this software layer above the hardware.
The hypervisor.
The hypervisor, in a way, the first step towards software-defined infrastructure, in a sense.
Right.
It let you do a bunch of other things that were really hard when everything was locked in on a physical server. So, yes, the hardware virtualization really became, not universal, but certainly became very, very widely used in enterprise data centers.
But it seemed like there was a spring of, I think it was in 2014 or 15, Docker just exploded on the scene. I think it would have been 2014. I'm not sure. I can't remember the year exactly, but suddenly it was like, containers came out of nowhere. Apparently, I know they had the history to them, but they appeared out of nowhere seemingly, and they began this very rapid upward trend in the enterprise.
Yeah, absolutely. And not just, the enterprise and probably initially even more so the web scale companies in Silicon Valley and the like. But yeah, and I'm a little embarrassed to admit that I wrote a book called Computing Next in about 2013, 2014, sort of where cloud computing where it came from, where it's going, and so forth. And I basically didn't mention containers.
You can put out a revised version of that. That's what I
would have just everything. Well, I did just come out with first version of a new book that talks about containers and packaging and so forth.
What is the title of your new book, Gordon?
Well, the title is just in pre-release right now, but it's From Pots and Vats to Programs and Apps. And it's about how software learned to package itself, and basically taking these lessons from retail and packaging historically. And there's a really great segue into what you just asked me, and how we brought that into software. And that was really what happened with containers in about 2013. Is yes, containers took advantage of this kind of historical operating system virtualization model. But what changed was they really became a packaging mechanism, a way to have application portability, across a range of different systems, including public cloud. So they really kind of took historical containers as as a working base, but they really added this patching mechanism, and then over time these orchestration mechanisms came in, and really this very broad cloud native ecosystem, like Kubernetes from the orchestration layer. And in fact, one of the things that's fascinating about what's going on in the container space today is that if you look at, for instance, the Cloud Native Computing Foundation within the Linux Foundation actually publishes what they call the Cloud Native Landscape. And it's this enormous PDF document. I mean, they could make a poster out of this thing. It's just all these companies playing in this space. And it's really this remarkable in many ways.
You mean the container space? You don't mean the orchestration space?
Well, it's all part. I consider it all part of the cloud native space generally, because the reason containers is interesting is, again, not because of just containers, and something like the runtime container format, the image format standardized under the Open Container Initiatives. That's interesting, but to really use containers effectively as part of really a computing system, and a computing system these days really means your entire data center and maybe multiple data centers, takes all of this orchestration, logging, monitoring, and all these different types of different projects, different applications, many of which are open source, and they all play together with each other. And that's really what's giving this, again, mostly open source ecosystem its power.
Well, now when you talk about playing well together, is containers going to make virtual machines obsolete? Or are they going to live together side by side happily?
Well, there's a couple of things going on. First of all, nothing that has become as dominant as virtual machines is ever going to die overnight. And there's still an enormous interest in, I don't really like using this word, it's a little pejorative, but legacy virtualization. But certainly the IT optimization side of things. Look, I've got at least a portion of my application infrastructure. It runs fine. It's not worth rewriting as microservices, containers, not worth moving to a public cloud. And it really makes sense to continue to maintain and even expand that part of the IT footprint. And Red Hat has a KVM-based virtualization product, and that continues to do very, very well for us. Just had a new release of it, so there's still a lot of interest of that in IT shops. The second thing is that in many cases, containers and virtual machines get used together. So, classic example is Amazon Web Services. Running, EC2 is virtual machine based, and you can absolutely run containers on top of that virtualized infrastructure. You can run containers on an OpenStack in virtual infrastructure on premise. And there's also work being done with containers specifically within the OpenStack project work. But you can also just have OpenStack and run a container platform like, say, OpenShift on top of that. So I think the answer is traditional virtualization stays around. The two get used in conjunction with each other. Certainly people are experimenting with running heavier weight, fat containers as well. And we'll see how this plays out over time. But certainly it's not a case of containers taking out virtual machines anytime soon.
Yeah. Good. All right. Clear up a misconception for me that I've been somewhat confused about is that when I was sort of learning about containers, I thought the containers meant that if an app was wrapped in a container, it could travel freely through many different computing environments. But I'm not so sure that's true anymore as I learn more about it. I mean, does a container need to be in a specific environment to be happy, or can one container travel between various computing environments?
So a container. So first of all, containers are within an operating system. They're within Linux. So there's a very tight connection between containers and predominantly Linux operating system, because it's the operating system that really creates that container environment.
Mm-hmm.
Containers are portable. I mean, that's one of the whole ideas behind them, that you have this portable file format, you have this portable runtime, can package up an application and move it from place to place. Now, having said that, you start talking about complex application environments. Talk about Google. No, you're not going to pick up Google and move it somewhere else.
Probably not. No, it's kind of heavy.
Where you have all, you have all the monitoring infrastructure, the orchestration infrastructure, all the other the connections to data sources, where physical locality may well matter. So absolutely, containers provide portability, but as with any of these things, as you get into bigger and more complex environments, it's not just as easy as pushing a move button and expecting that you can move it halfway, all your data and all your applications halfway around the world to another data center.
Gotcha. Okay, so a container is not going to bounce happily from a Linux environment to Windows environment, like a truly heterogeneous environment. It wants.
Well, and again, containers are, and to your earlier question about VMs. Well, yes, it may make sense to have your Linux containers running in a VM on on Azure or whatever, for example. Mm-hmm. And I mean, there is definitely work going on in terms of kind of broader container interoperability. Like Microsoft is doing some work in terms of running Linux containers on Microsoft Windows, for example. And so absolutely the goal is to increase and enhance portability across as many environments as you can. But you're being a bit disingenuous as you just say, oh, sure, you can just move it anywhere you want, however you want.
So really, the upswing and the trend upward in containers is a victory for open source in many ways.
Well, yeah, I mean, again, you look at the projects involved in, again, cloud native computing generally, in terms of the OCI runtime, the OCI image format, from kind of the base level point of view. But then you look across the Cloud Native Computing Foundation, which that's not where everything lives, but there is sort of a center of gravity. And Kubernetes, FluentD, Linkerd, Core DNS, Prometheus, and lots of other projects that I'm not naming. Again, I think there's literally dozens of them just in that one matrix. And I think it absolutely is a victory for open source. And I think at the sort of most simplistic level, well, yeah, all this stuff is open source and it's enabling cloud native computing. So yeah, open source has gotten a huge amount of the mind share and is delivering a huge amount of the benefit to users in that space. But I would argue actually that the open source winning, there's more, maybe even more important and somewhat more subtle points there. Because one of the things that this cloud native space is really showing is how powerful open source is as a development and collaboration model. Because before open source, there is no way. I mean, there probably aren't enough lawyers on the planet to write the contracts that would have been needed to have collaborating in this way. And instead, engineers from different companies just go up to GitHub. And yes, there's still lawyers involved for trademarks and foundation governance and those kind of things. But I think what probably was certainly not widely recognized, and I'm actually not sure if even any of the principals who were involved in early open source early on really fully grokked this kind of collaboration it would enable, because I think it was much more wrapped in the user freedoms and those kind of things, which are absolutely important, but where I don't think it was probably appreciated that outside of the ideal, sort of the ideological and protection of the users, I don't think it was widely appreciated just how powerful open source would become as a development model.
Oh, I mean, absolutely. And this certainly is probably a separate 6-hour topic, but it's fascinating how open source has sort of moved from sort of this developer, very developer-centric world of the 90s where we loved it. We get to all work together. And then like corporations slowly understood, open source, that can be a huge tool for us. And I mean, the war is over and open source has won. And it has gone so far from those early days of developer-centric.
Yeah. Now, I will say, and I say in my new book that it's not all, unicorns and roses and rainbows and the like. I mean, on the other hand, you do have these big cloud providers, some of which are better at participating than others. I mean, give Google credit. They Kubernetes came out of their internal work, and they have Sarah Novotny on board now as a community manager for Kubernetes, and they've really, I think they've really learned how to work better in the open. Microsoft has made very significant strides, obviously.
Yeah.
Amazon, perhaps somewhat less so.
You're being very diplomatic, Gordon. Very diplomatic.
Amazon. I mean, Amazon does a lot, and certainly they make. They've been a big boon for a lot of developers who walk up and running quickly.
Right.
But they haven't been as big a contributor to open source as some of the other equally large cloud providers.
I think that is clearly agreed upon. Yeah. So why? And you may have mentioned this, but I'd love to put it in a nutshell if we can. Why are containers such a good fit for cloud computing?
Sure. Well, the portability we talked about.
Right.
The other thing, I'm not. So it sort of depends how we're defining cloud for this answer. So let me answer a slightly different way. Why are they such a great fit for cloud native architectures?
Okay.
And a couple of reasons. So first of all, the Snowflake customized operating system images that we associate with virtualization, we don't do that any longer. We're using very standardized operating environments, very large scale out operating environments, where the idea is these immutable instances, you put them out there, and if something goes wrong or if something untoward changes, you kill it and start a new one. We're also of this idea, and this is still, I'd say, a little bit in flux, but this idea that we're tending to move from big monolithic application architectures to these more loosely coupled microservice based ones.
Right.
Well,
clearly. Yeah.
So you have a small service, a container, where it's immutable. You've got lots of them. You fire them up. They may not live very long. Oh, and a container is a small, lightweight container that can be fired up very quickly, destroyed very quickly, doesn't take up a lot of resources. So, that fits together. And by the way, we're also moving to these more agile DevOpsy style development processes where you have a lot of automation, automated testing, automated deployments, canary deployments, blue-green deployment. Again, very good fit for a container. So from my perspective, what's happened is you have, sometimes things have been around for a while, but the soil's sort of rocky and stony and isn't very good mix for them. And then you suddenly have this different type of environment with different types of priorities. Because the other thing I'd say is that you ask most CIOs today, you go back, certainly around 2008 and go, what's your number one priority? Saving money.
Right.
You ask your CIO today, average CIO today, and they still care about saving money, but they also really care about, things like enabling my company's digital transformation journey, partnering with the business, deploying new revenue producing services more quickly.
Competitive advantage, right?
Competitive advantage. Technology is a competitive advantage. And again, this idea that you can have these sort of new application architectures to support new business models, to support new types of services, to support new business opportunities. And you can do it with these kind of very scalable, agile sorts of infrastructure with containers developed using DevOps. And all this stuff really kind of plays off each other and fits together.
So, I mean, you've said a lot of good stuff, a lot of good information. I guess I'm really curious about where it's going, because it's container technology feels like it's very much in flux. Things coming and going constantly. Where are we going over the next couple of years with container orchestration engines and with containers? I mean, where is this headed in the next few years?
Yeah, well, obviously, I wasn't very good at predicting the last time I tried this.
Well, I'll tell you, but, no one could put a technology book in print and then look smart 3 years later. There's no one who's ever done that. It just doesn't work that way.
Yeah. Well, so I mean, there's a few things I'd say. First of all, I actually think the technology is going to stay in a lot of flux with these projects.
Really?
I mean, there's still a huge amount of innovation going on. What we're seeing is limited standardization where you need that standardization in order to innovate on top of it. So, for example, I referred to the Open Container Initiative before, which again is also part of the Linux Foundation. And in contrast to CNCF, they have a very narrow focus on what are some of the specific areas of containers, which happens to be the image format and the runtime now. They're also looking at distribution and potentially some other things where, okay, we have something that works here today. This isn't, we'd really like to kind of standardize in this area so that people can just plug into this, but can have some confidence this isn't going to be rapidly changing.
Right.
Now, the challenge, what I just said probably terrifies some of your listeners because
they don't want the standardization.
This idea that all this stuff is going to be in flux and I'm going to have to learn new stuff all the time. Right. And what we've actually seen happening here is particularly a lot of the bigger tech companies, banks and so forth, kind of in round one, they go, wow, all this open source, all this stuff I can just download and try. And then, a year later, it's, well, my devs have really good looking resumes now, but I don't actually have something I can use.
Right, but the devs have learned a lot and they've had a great time.
Yeah. So one of the things that we see at Red Hat happening is not to do too much advertising here, but we have a container platform, OpenShift, where we basically pull a lot of this stuff together and make some choices about where things are mature, do integration work, that kind of thing. And there's definitely a lot of interest out there in we either need a dev platform or we need just a container orchestration platform for our ops teams. but we'd really like someone to do this for us. And there's a lot of interest there, including do-it-yourselfers who have kind of come, who we had spoken with and who were sort of like, yeah, thanks, but we're smart. We can do this ourselves. And it reminds me of the old days when there were banks who had directors of kernel engineering for Linux.
What year would this have been?
That was probably, I was at Illuminata at the time, so this would have been late 90s.
An actual bank had something called a director of Linux kernel engineering?
Yeah, I've been told that anyway. I'm not sure I ever met. Excuse me, this would have been early 2000s.
Early 2000s.
Yeah.
Okay.
Yeah.
That's fascinating.
There were still a lot of financial organizations. They still do a lot of customization, but increasingly, I think there's been a recognition that there is like an infinite amount of technology work to be done at a lot of companies, and certainly at financial institutions and so forth. And if some of that work can be easily done with someone who frankly has a lot more expertise in it than you do, why not?
So your bottom line though is that the flux will continue going forward. We're not going to get into 2019. It's not going to all settle down with a standard and just like continue on smoothly.
I think we'll have standardization some areas. So Kubernetes we've talked about, for example.
Right.
I'm not about to say Kubernetes is the orchestration winner, and it's going to somewhat depend on workloads and that kind of thing. But if you look at community size, you look at community momentum, I think you look and say, I feel reasonably confident saying that, hey, Kubernetes, that's going to be the mainstream standard container orchestration platform.
Okay, no, that's a good prediction. All right, I like that's a good solid prediction.
And I think you can look at some other particular projects in the CNCF and elsewhere. I mentioned Prometheus. There really is. Again, I don't think you're going to have a single monitoring and alerting solution, but that's something there seems to be a lot of momentum behind. And you can kind of continue down the list. I think there's going to be areas where you start to say, yeah, that's going to be the 80% solution.
Right.
And then I think you look at other areas like serverless computing, for example, which are pretty new. Amazon announced Lambda, I guess, a couple of AWS reInvents ago.
Right. Function as a service.
I'm not sure how much momentum it has at this point, but
it feels like it has a lot. I'm sensing.
There's certainly interest in the idea, and then there's the question of, well, what do you do with that you don't do? What you can't just do with a regular container.
Okay.
And set up your own event triggers and things like that. And then you get into the whole question of, do I really want to write my application so it can only run on Amazon? And it depends how much do you want to go in that. But on the other hand, there's some open source serverless computing. I actually really hate serverless computing in terms of functions as a service. They
you like function as a service better than you like.
I like function as a service.
Yeah,
there's still
a lot
server
of
and there's still an operating system. Yeah, so there's definitely some work going on there, and I think that's an area that we could see some expansion in.
So, I mean, I think you said it, Gordon. Any last thought before we wrap up today?
No, I mean, I've been in the industry for a little while, and this has really been last few years. I mean, have really been pretty, remarkable. I mean, I think certainly starting about 2010 with cloud going from, well, when we say cloud, what we actually mean is a self-service portal on our virtualization solution to really genuine cloud native, cloud.
Yeah.
Also, people going from, the public cloud is insecure. No, it's not. The public cloud is insecure. No, it's not. You know, these kind
the
of
cloud is more secure than in-house. It seems like that's
well, and in some cases it is. Well, and my point is, people are better understanding use cases and having more sophisticated discussions about them. So that's but and then containers coming in, and I think almost, I wouldn't say changing everything we knew about infrastructures and writing applications, but the whole DevOps, cloud native microservices, containerized platforms, etc., has changed things pretty radically over the last few years.
Absolutely,
and
it has gone crazy the last, say, 2 to 3 years in particular.
Yeah, and you know, kind of what comes next. You know, I think absolutely that, you know, I think a lot of innovation does take place here, but I think the normal cycle is you would expect some degree of stabilization in this space. And you know, I think there's certainly still questions over kind of how does, you know, private versus public cloud play out. You know, how you know, to what degree people do end up switching over to software as a service for certain things. And again, it's going to depend on the size of the organization and so forth. You know, I think, you know, certainly there's a lot going on, and you know, what you might call the CIS and developer space. There's a lot of effort going on in the development space. You know, how do we make it easier for more people to develop, for these business users to develop applications. So I think that's something that is going to go on. But I'm really just seeing this sort of Cambrian explosion. I mean, we didn't even get into things like, I mean, we've really been talking infrastructure here mostly. So, you know, not even talking about the number of development languages and so forth out there exploding.
Right.
You know, IoT is going to impact all of this. That's in very early stages.
Right, it is.
And you know, there's still a lot of questions there, but certainly companies like GE are getting enormous benefit out of it.
Yeah, GE is hip again. It seems like with the IoT thing is going on. GE is, you know, it's pretty cool.
Yeah. So you know, so I mean, those are, I think, some of the areas, and then obviously in applications, you know, where does the whole, you know, AI, machine learning, etc. type thing. And all of this stuff isn't related to containers directly, but I think it does point. Yeah. It kind of is, because things like data and application portability are important there. I think it just points to all this stuff runs on computers. It runs on operating systems,
right?
You know, so this stuff isn't going away. It may be under the covers as far as the average developer is concerned, but is aptly still there, and it's hard not to see there going to be a continuing insatiable appetite for.
Well, you blanked out there at the end. Appetite for what?
For computing.
Oh, absolutely. No, it's only going to get larger and larger. Yeah. Gordon, I think you said it. Thank you very much for your expertise. It's a lot of fantastic stuff. It's unusual things ahead, to be sure. Interesting things. So thanks a lot. I'll talk to you soon.